Hello everyone. Today we will learn about even numbers, odd numbers, prime numbers, composite numbers and co-prime numbers. So let's see what are even numbers. Any number when divided by 2, if it leaves remainder 0, they are known as even numbers. Similarly, any number when divided by 2, if it leaves remainder 1, they are known as odd numbers. Example of even numbers are 0, 2, 4, 6, 8, 10 and so on. Similarly, example of odd numbers are 1, 3, 5, 7, 9 and so on. Now if we see these numbers, let's derive a general form of even numbers. So general form of even numbers, can we write it as 2 into n or simply 2n, where n can be any natural number 1, 2, 3, 4, 5 or even whole numbers. Okay, so 2 into 0 is 0, 2 into 1 is 2, 2 into 2 is 4 and so on. Similarly, general form of odd numbers. So general form of odd numbers can be written as 2n minus 1 or 2n plus 1. See here, if we substitute n with 0, we get 1. If we substitute n with 1, here we get 3. But here we get 1. If we substitute n with 2, here we get 3, here we get 5 and so on. So we can clearly say that the general form of odd number is either 2n minus 1 or 2n plus 1. Similarly, let's see some calculation of odd and even number. So odd plus odd is even. How? Let's see. Say for example, as we said, we can denote odd number as 2a plus 1, where a is the natural number, plus 2b plus 1, where b is the natural number. So this we can write as 2a plus 1 plus 2b plus 1. Taking 2 out as common, we can write as a plus b plus 1. Now any number multiplied by 2 is always even. So here we can take a plus b plus 1 as our n. So this is 2 into n. So any number multiplied by 2 is even. So we can say that odd plus odd is even. Another ways of simply saying is 1 plus 3 gives us 4. 2 plus, sorry, 3 plus 5 gives us 8. 7 plus 11 gives us 18. So addition of two numbers simply gives us even number. Now let's see odd plus even. Now odd plus even is always odd. Similarly, even plus even. Even plus even is always even. Now what is odd into odd? Odd into odd is always odd. How? Let's see by few example. 1 into 3 is 3. 3 into 3 is 9. 5 into 7 is 35. So all are odd, odd numbers. Similarly, odd into even equals even. Let us see this with a couple of example. Say, suppose if 6a plus 3 equals odd, is a odd or even? So now we know that the value of a can be, say, we can put, both odd and even, but we are seeing that a is being multiplied by an even number. So any number when multiplied by an even number is always even, and plus an odd number will give some odd. So a can be any value. So a can be either odd or even. A can take any value. Similarly, if we say 8a minus 4 equals even, is a odd or even? Similarly, here we are seeing a is being multiplied by an even number, and even that always gives an even number, right? And even minus even is even. So whether we put the value of a as 1 or 2 or 3 or 4, when it's multiplied by 8, it will always give an even number, and even minus even will always be even. So a can be anything. A can be even or odd, right? Now let's see prime numbers. So what are prime numbers? Prime numbers are those which have exactly two distinct factors. The keyword is exactly two distinct factors. Okay, I understand the word factor is new to you. We will see what it is. So what is factors? So factors are those numbers which completely divides the given number. That is, factors are those numbers which completely divides the given number, which means the remainder is always 0. So let's see few example. What is factor of 1? Factor of 1 is 1 because 1 is divisible by only 1 when it reaches remainder 0. Factor of 2 is 1 and 2. Factor of 3 is 1 and 3. Factor of 4 is 1, 2 and 4. Factor of 5 is 1 and 5. Factor of 6 is 1, 2, 3 and 6. Factor of 7 is 1 and 7. Factor of 8 is 1, 2, 4, 8. Factor of 9 is 1, 3, 9. And factor of 10 is 1, 2, 5 and 10. And so on. We can write factor of 11, 12 and so on. Now let's see composite numbers. So composite numbers are those numbers, okay, which have more than two distinct factors. So for prime numbers have two distinct factors, while composite numbers are those numbers which have more than two distinct factors. So we can write it as any number having more than two distinct factors. Now let's see, is 1 a prime number or a composite number? So we can see that 1 has only one factor. So it is neither a composite number nor a prime number. While 2 has two distinct factors, so it's a prime number. Similarly, 3 has only two distinct factors, so it is a prime number. 4 has three distinct factors. So more than two distinct factors is called composite number. So 4 is a composite number. Remember one thing, 4 is the smallest composite number. Again, 5 is a prime number, 6 is a composite number, 7 is a prime number, 8 is a composite number, 9 is a composite number, 10 is a composite number. Now let me tell you, do you know how many prime numbers are there between 1 to 100? So let me tell you, there are exactly 25 prime numbers between 1 to 100, and they are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So remember this, that there are exactly 25 prime numbers between 1 to 100. We will use it in future. Now let's see another fact. Okay, so any prime number greater than 3 can be written as either 6n plus 1 or 6n minus 1. So this is true only for prime numbers greater than 3. So let's see, can 5 be written as either of the form? So 5 can be written as 6 into 1 minus 1. 7 can be written as 6 into 1 plus 1. 11 can be written as 6 into 2 minus 1. 13 can be written as 6 into 2 plus 1. and so on. But the vice versa is not true. What I mean is, any prime number greater than 3 can be written in the form of 6n plus 1 or 6n minus 1. But any number that can be written as 6n plus 1 or 6n minus 1 may or may not be prime number. But the converse is not always true, right? That is, any number that can be written in the form of 6n plus 1 or 6n minus 1 may or may not be a prime number. Let's take some example. 35. 35 can be written as 6 into 6 minus 1, where the value of n is 6. But 35 is not a prime number. We have factors of 35 as 1, 5, 7, 35. More than two distinct factors. Similarly, 55. 55 can be written as 6 into 9 plus 1. And we know that 55 is not a prime number. So any prime number greater than 3 can be written as 6n plus 1 or 6n minus 1. But any number that can be written as 6n plus 1 or 6n minus 1 may not be prime. So can we say that now by understanding all this, can we say that natural number is nothing but a group of prime numbers, composite numbers, and 1, right? Now let us understand one more type of numbers, that is co-prime number. So a pair of numbers are said to be co-prime if they don't have any factors in common. Obviously, except 1, because 1 is a factor of all the numbers. So let us see. So prime number, I mean co-prime number in itself is not a single number, but it's always a pair of numbers. So two numbers can be called co-prime when they don't have any common factor except 1. Say for example 2 and 4. Are they co-prime? So the factors of 2 are 2 and the factors of 2 are 1 and 2, and 4 are 1, 2 and 4. So they have 2 in common. So it is not a co-prime number. 2 and 3, Yes, they are co-prime number because the factor of 2 are 1 and 2 and 3 are 1 and 3. So they don't have any common factors apart from 1, so they are co-prime. 4 and 5. So the factors of 4 are 1, 2 and 4. Factor of 5 are 1 and 5. They don't have any factor in common except 1, so they are co-prime number. 8 and 9. The factors of 8 are 1, 2, 4 and 8. The factors of 9 are 1, 3 and 9. They don't have any factors in common except 1, hence they are co-prime number. 6 and 9. The factors of 6 are 1, 2, 3 and 6. The factor of 9 are 3 and 9. So they have 3 as a common factor, hence it is not a co-prime number. Similarly, we have 9 and 11. They don't have any factor in common, hence they are co-prime number. I hope it's clear. Thank you.